Hi everyone. In this given problem statement, you have to find maximum subarray. So this type of problem, right, can be solved using Cardin's algorithm. So what is it, right? So if I have to find the maximum subarray, right, one way would be right to find all the subarrays, and that is going to take me of big O of n square. And here, right, it's been written that we have to figure out a big O of n solution. So how to do that? So let us try to understand it, right? So a Curtin's algorithm says, right, there could be two scenario. So we are going to, so for here, right? So we are going to keep a track. We are going to keep looping through and keep a track of the subarray. Subarray sum, and the other would be the current value. So scenario one, let's say sub sum and the current value. So in this scenario one, right, if my subarray sum is positive and the current sum is positive, right, then we are going to extend it. Or let's say we are going to result, let's say extend, means we are going to add the current sum to our current subarray. The scenario could be the subarray sum could be negative, but the current value is positive, then it's better to start a new subarray. So I will start a new one. The third one could be, if this is positive, the current subarray sum is positive, but uh, the current value is negative, then also let us extend it, because if we extend it, right, it will not reduce the current subarray sum. And the fourth scenario would be, if both of them are negative, then there is no point, we can create a new one. So let me just explain how it is working. Let us take this example. Okay, 5 4, or let us take this example of big one, right? So the current sum, or let's say subarray, right, subarray sum and the current val. So current val is -2. Okay, and the initially, right, it would be 0, so there is no point of adding it, right? So we are just going to the next one. So next one would be 1, so I can add 1 to my current sum. Similarly, it will be -3, the current value. So the current value is negative. Okay, so it's -3. So what I can do, right, here you can see, right, so let me add it up. So it would be -2. Once it -2, right, we are getting a value of 4. So whenever we get a value of 4, so we add 4, we are starting a new one. Okay, and here, right, we will always keep our track. So current max would be 4. Then we are getting -1, so let me reduce it to 3, because current sum is greater, so we will add it. Then 2, it will make it 5. Then we are getting 1, so 1 we can add it to make it 6, so max value, and we also keep on updating the max value also. Then the next one is -5. So if I, because the current subarray sum is positive, right, and the current value is -5, so we will have to add it. So it will be 1, and then it will be 4. So 4 I can add it to make it 5. But the maximum that we got, right, in the current subarray, which was the value from 4 to this one, so this is the maximum value that we got. So it was 6. So the maximum value was 6, and this would be the result. So I hope you are able to understand, right? And let me jump to the solution. I think that is going to make things even more clearer. And the time complexity of it, right? Because we're iterating through this entire array once, so it would be big O of n. So the first thing that we need to do, right, we have to create our subarray sum, which is going to be 0. Max sum is also going to be 0. And let me iterate. So for n in nums. If my current subarray sum, if array sum is less than 0, in that case what I can do is I can initialize with 0. So sub array sum equal to the current n value, else I can say sub array sum plus equal to n. And in the other cases, right, I will also have to keep a track. So if sub array sum is greater than the max sum, so in that case the max sum will also increment. So max sum equal to the current sub array sum, and I can return it, return max sum. Let me run the code. As you could see, the public test cases are passing. Let me submit it up. There is one case, right, where it is giving a result or giving a negative value. So in that case, right, I can say I will always have to increment or decrement it, right? So I can say this current one would be nums of 0, okay? Because I will have to add at least one value, and that could be, we can start it with the current or 0th value. Let me run it again. And as you could see, the test case is passed. It is beating 90.87 because it's a linear time solution. So that's all for this video. See you in the next one.